Hello ladies, it's Mr. O'Sullivan. Today we're going to be looking at lesson 3-5. This is a Zoom lesson, so please make sure that you attend the class. That way you can ask any clarifying questions you might have. Today's learning target is I can write the equation of line by analyzing a word problem and using slope-intercept form. When I say word problem, I don't necessarily mean like, oh, John has 5 bars of chocolate, Miss Townsend has 3 bars of chocolate, write an equation. What I mean by word problem is I'm giving you a verbal description of the situation. I want you to write the equation. So when we talk about slope-intercept form, this is something that should not be a surprise. You've been doing slope-intercept form for the past few days. Slope-intercept is y equals mx plus b, where m is your slope, or your rate of change, and b is your y-intercept, or your start point. Your start point. So when we do these questions, we need to be very careful because you're not always going to be given the necessary information. You're going to have to possibly find the information. And just a heads up, 2 items are needed to write the equation of a line. You just need the slope and you need any point. Literally, any point that is on the line. If your line is vertical or horizontal, now when I say vertical or horizontal, what I mean is a Hooyvoets line. So if you have a Hooyvoets, which is our y equals or x equals a number, so like Hooyvoets. So if you have y equals a number or x equals a number, you don't have to find the slope at all. You just write the equation and you skip the rest. Make sure you write your equations in slope-intercept form, so y equals mx plus b. And make sure that if your equation's not in slope-intercept form, you solve for y. Now recall, how do we find the slope between 2 points? There are 3 ways we look at it. The first way I prefer, this is the way I prefer, but a lot of you don't prefer this way, which is fine. I like delta y over delta x, which simply means the change in y over the change in x, which is the exact same thing as y2 minus y1 over x2 minus x1. So you can use one of those 2 ways, or if you're looking at a graph, use rise over run. And make sure you take account if it's positive or if it's negative. Special lines do not follow these rules. So for instance, here's how when I say special lines, I still mean the Hooyvoets lines. So Hooyvoets again. You can tell if a line is special by simply just looking at the x-coordinates and looking at the y-coordinates. So look at your x-coordinates. Are they the same? Look at your y-coordinates. Are they the same? And if you can say yes to one of those questions, then you have a special case. And we'll be going over those examples. You were literally writing the equation of a line all week. So if it's not specified, your equation can be written in any form. It can be written in point slope, which we really aren't going over this year. It can be written in slope-intercept, or it could be written in standard form. Thing is, standard form is very annoying to write in, so 99% of the time, we're just going to write it in slope-intercept form. So question number 1, write the equation of a line with a y-intercept of 0, 5 and an x-intercept of negative 4, 0. Remember, we're writing the equation of a line in y equals mx plus b form. So if I look at this, I don't have my slope. So what I want to do is I want to find my slope. So the first thing I do with these questions, I always rewrite y equals mx plus b. So step 1, find your slope. My points are 0, 5, and negative 4, 0. So I'm going to find the slope of these points. You should be finding the slope also. It shouldn't all be my job. So slope is y2 minus y1 over x2 minus x1. So the first thing I'm going to do is I'm going to go to my points and write down my x, my y, my y. So y2 minus y1, so I start with my 0 and then I go to my 5, over, go to my second x, go to my first x, negative 4 minus 0. When I do 0 minus 5, I get negative 5. When I do negative 4 minus 0, I get negative 4. If I type that on my calculator, I should get like 1.25 or something, I think. The thing is, I don't want decimals, I want fractions. I actually do want fractions. Fractions are much nicer. And they both have a negative, so what I can do is I can cancel out my negative. So I can say my slope is 5 over 4. Good, we have our slope. Now we want to find our y-intercept. So if we look at our question, I tell you what the y-intercept is. I said my y-intercept is 0, 5. So I know my y-intercept is just 5. So now we put it all together. We have our slope and we have our y-intercept. So y equals mx plus b. Our slope we said was 5 over 4, so I have y equals 5 over 4 x, and my y-intercept is 5. That's my final equation. Y equals 5/4 x plus 5. Now what we're going to do is we're going to go on to another example. Write the equation in the following line in slope-intercept form. If I look, we remember that our slope-intercept form equation is y equals mx plus b. M is our slope. B is our y-intercept. So when I look at this, I don't know what my slope is and I don't know what my y-intercept is. So I'm going to actually have to do a little work to find my y-intercept. So whenever you have a graph, you just do rise over run. So let's find our slope. So if I look, I start at negative 3. I'm going to go up 2, right 1. Up 2, right 1. So I can say that my rise is 2 and my run is 1, which means that my slope is just 2. Now, I know my equation is written as y equals mx plus b. So what I can do is I can put that 2 in for here. So I have y equals 2x plus b. I don't know what my y-intercept is, so what I'm going to do is I'm going to pick my favorite point. I like this negative 3, negative 3. So I'm going to substitute a negative 3 in for my x value and a negative 3 for my y value. So I have negative 3 equals 2 times negative 3 plus b. I get negative 3 equals 2 times negative 3, which is negative 6 plus b. The only way to get rid of minus 6 is to add 6. Add 6. So I get b is equal to 3. Now that I know what my y-intercept is, I can go in and put that into my equation. So my final equation is just going to be y equals 2x plus 3. And that's your final answer. You actually didn't need to do this algebraic approach. I did this algebraic approach because I like to do algebra. But you could have just worked a little smarter and not harder. I can rise 2 from a y-coordinate of 1 and run 1. That'll bring me to my 0, and this will be the point 0, 3. So that's my y-intercept. Let's go on to the next page. How to tell if a line is special. Look at your x-coordinates, look at your y-coordinates. Are either of them the same? Go back to the front. Ooh, special case. Look at your x-coordinates, look at your y. Okay, so write the equation of the following linear function in slope-intercept form. Well, we don't know what our slope is and we don't know what our y-intercept is. So the first thing we want to do whenever we're given a table is we want to calculate our jumps. When I go from 2 to 4, I go up by 2. 4 to 6, I go up by 2. 6 to 8, I go up by 2. When I go from 1 to 6, I go up by 5. 6 to 11, up by 5. 11 to 16, up by 5. So remember, slope is the change in y over the change in x. So what I can do is I can say my slope is 5 over 2. So we know y equals mx plus b. So I can say my slope is 5 over 2. So y equals 5 over 2 x plus b. I don't know what my y-intercept is. So now what we're going to do is we're going to pick our favorite point, and then we're going to solve for b. I'm going to choose my 8, 16. This is my x value. This is my y value. So I'm going to plug that into my equation and solve for b. So I have 16 equals 5 over 2 times 8 plus b. I have 16 equals 5 over 2 times 8. I type that into my calculator and I get 20 plus b. The only way to get rid of a 20 in math is to subtract 20. My 20s cancel and I get b equals -4. What I can now do is I can plug that back into my equation and get y equals 5 over 2x minus 4. And that's your final answer. I didn't have to do the algebraic approach though. We know our y-intercept occurs when x is equal to 0. If you look, I'm going up by 2 each time, and I'm starting at x equals 2. So if I want, I can go backwards 2, and I'll end up at 0. I notice that I'm going up by 5 each time, so I can actually go backwards by 5. 1 minus 5 is -4. And look, that's my y-intercept, which is exactly what I got when I solved algebraically. Okay, number 4. Write the equation of a line with a slope of -1/2 and a y-intercept of 2 in slope-intercept form. Well, I have my slope and I have my y-intercept. I can just go ahead and write it. Remember, slope-intercept is y equals mx plus b. M is our slope. B is our y-intercept. So what I can do is I can put my -1/2 in for m, and I can put my y-intercept of 2 in for b. So my final answer is going to be y equals -1/2x plus 2. And that's your final answer. Let's go on to number 5. Write the equation of a line that passes through the points -3, 4, and 5, 4. Well, the first thing I can do is I can find my slope. So slope is equal to y2 minus y1 over x2 minus x1. So y2 is 4, y1 is 4, so I do 4 minus 4 over 5 minus a -3. 4 minus 4 is 0. 5 minus a -3 is an 8. 0 divided by anything is a 0. So here's the issue. I don't really know what to do when my slope is 0. But if we go to the front of our page, well, if I look, my y-coordinates are the exact same. So this is a special case. I actually don't even need to find the slope. I can just go ahead and write the equation. Both of my y-coordinates are 4, so I can say that the equation of this line is just y equals 4. It's a y over a vux. It's a y. Number 6. Write the equation of a line that passes through the points 1, 4, and 1, -1. I can find my slope. Let's find it. Slope is y2 minus y1 over x2 minus x1. My second y value is -1. My first one's a 4, so I have -1 minus 4 over 1 minus 1. If I type that into my calculator, I get -1 minus 4 is -5. 1 minus 1 is 0. If you type -5 divided by 0 in your calculator, you're going to get error or undefined, which is basically a fancy way of saying no slope. So I don't really know what to do when I have no slope coordinates. If I look at my x-coordinates, they're both a 1. So what I can say about this line is my equation is just x equals 1. And that's your final answer. This is a vux over a y. And that's it for today. If you have any questions, please email myself or Miss Townsend or Miss Jimenez. Have a great day, ladies.